All right, welcome everyone. I will come around and check your notes once you're working on the activity for today. Just to sort of give you an overview of where we are in the course, here's our course schedule, and the homework numbers on here are not quite right, but we are right here talking about confidence intervals, and there is no quiz this week because we have an exam coming up next week on the 14th. So you may want to start thinking about what you want on your note card for that, and I will get a practice exam posted later this week. All right. Yep, so it'll be available after class on Wednesday and until right before class on Friday. So same as last time, but different day of the week. Correct. Okay. Yep. All right. So are there questions about homework 10 that's due on Friday or homework 11 that's due next week? Perfectly reasonable if you haven't started homework 11 yet. That covers today. Where are we at? That covers material from so homework, yeah, homework 10 covers today, material from today and tomorrow. Homework 11 covers material from Friday and Monday then. All right. Are there any questions about the video that you watched for today? Okay, so I'll give you back control of the computers so that you can use the applets to help you come up with a confidence interval for the percentage of couples who turn their heads to the right versus the left when they're kissing. Really?
Not this version, but like the kissing right to left.
Huh. I didn't know I saw it. And for folks watching this recording later, this is the kissing right activity that's right here. At that point,
This one is really well ready. I looked at the one and that was due to these. 24 couples, maybe it's like great. You're not making a lecture on it, you know. I don't know what I'm doing. How am I supposed to ask questions? Yeah, I would put up like this and it bent back.
Every single night, we do I came back super sore. Yeah.
Everyone's so well. I was like,
My body's but it's work and I make games, so like football. I still running this week. One of the weeks I was like sprinting, and of course I just started sprinting like a lot. I fractured something.
I've heard that. It's better. I don't think it's broken. In Germany.
I think it's swollen or not?
Kind of. But like, I can bend it now.
Well, that's not. So,
Before I.
a couple days ago, like we have triple stuff, then yeah.
It's okay. Before I can bend it, I'll do it.
If you're ever like crippled, I would just tape to like a fence, right? And then the ice, you go to the doctor, that's gonna charge you, so
I know.
literally put a split on it, so ice, literally you gotta
I was just.
get a popsicle stick and get tape.
Right.
I don't know if you guys know, you guys know Chris is? Chris is? I want to like, just like, I just like fracture. Yeah, all they do is put her finger in the splint, and they hit, charge her $250. She really could have got a popsicle stick, just tape her finger to it.
She's got a popsicle over
So.
So that's the people.
So.
That's a high end. It's 0.5.
Right, you don't have that. Yeah.
Is this interesting when there's no?
Yes. Where's my little, I think this is possible. Wait, from the.
Is 0.6.
Where we get from this ride?
But like,
I don't know, I was wondering if you use that kind of way. Testing was different from.
so I was the significance would be.
No, look at problem 4.
No, how about,
So it's possible, I can look.
Yeah, no, I put it.
It's like 74 in the way.
I got it, right.
Okay. Same thing.
Oh, it's 0.02.
Is it just because they use the data or just?
No, I think it's because I did number instead of using.
All right, so still kind of.
So it's still low.
So, yeah, if we're at the significance level, then it is possible. This is rejected the ball.
Yeah, we're less, we're lower than that.
Yeah.
So.
So, yes.
Yeah. I'll say yes.
It's not hard.
I was gonna say yes. So
Yes.
stay with the.
That's what yes.
This is. I don't think it's, no, right?
I think this is
plausible.
Yeah.
It could be plausible, right?
Yeah. That just means.
Do people have a preference? Does it possible that people do?
Does this prove that?
And I've got.
it's equal to that? No, but it's
So
possible.
it's, okay, I said, yeah, I said, no, it's just that's impossible.
No, but it's possible.
But it's not for sure.
But-
Because that's the no. That's the growth. Red flags.
I guess, yeah.
So we're just changing that. We're just changing that. Two-sided feedback. And then, yeah. So what do you do? Okay, yeah.
One, 7, 5.
So,
Oh, the first one.
so it's. so
Oh, we're testing all these.
So we're just.
Okay.
We failed, but it's better than.
Okay.
Bar.
0.2.
So two-sided.
Yeah.
So I can put that in.
Right? And they're all rejected.
Probably until we get close to 60, but.
No.
Yeah.
No, I think you're right. I'm just saying if they're all
But if we get 20.
These should be, it's basically.
So I think like, yeah, I think once we get closer, it's gonna be possible, and then the farther we get.
These are quite big.
But yeah.
0.76.
No, it's very- it's not point ten. Which is not. Possible, but not like so large. Yeah. Actually, I don't know.
So, two associates, I don't know.
So, yeah, in general, you can't, but not hypothesis.
Unless they're getting closer to 60, so it's less interesting.
But they're
How do we?
Remember, you want values further away from 0.6 because
plausible, probably, one is also plausible. Oh, it's
Small
because if you got a huge sample size.
smaller p value is better, so it's getting bigger, it's getting closer.
Plausible.
Slowly.
So, yeah, unless you could sample everybody and find out the proportion is exactly 0.601 and 3 or whatever, then you would know the value. But that's one of the reasons why we use confidence intervals to give us
Hey,
a
we're almost.
range of.
Wait, 0.05, oh, we're not even close. We're pretty close.
Yeah.
Seems gonna be around.
Push them.
Yeah, something wrong.
Yeah.
That value is possible. It can't all be in
Going to the proportion I use is everything with I say, let's do 0.5.
0.76. That one's so far away. No, we're trying this one. That takes away from that. So that one's.
Wait, I think it's just using it.
What were you doing?
I've been reading up here.
Oh, yeah.
What's that change?
Right.
Right.
Which is why we can't prove it. Yeah, but like how do we use this in this class? Yeah,
It's
well,
for us.
I mean, it's possible that none of them are gonna equal it, right? So for the or.
I think, yeah, because if we're setting this.
Oh, it's
Plus
started.
So it's less. Plus
So
six
it's
is not
why
gonna
is
be
it
far, it's not gonna be far in the tail of
Okay,
the entire.
Because we want it to be like, I think if we're doing it wrong. They have a hard number 5. We should be. So are we?
I didn't see it, it's my resources.
Yeah, I know, but-
Sorry, but. So these are all.
And this stays as 0.3.
Is this?
So we can just multiply by 2. Yep, so that would say the same as the value in the data. Or maybe this one doesn't do two-sided ones.
Oh.
Oh, yes. Kind of is not.
Check.
Uh,
0.645.
So should this be 0.6? Why is it?
Well, what is we're probably just rounded what happened? So.
Rounded like this.
Well, you know, maybe I don't know. 0.
So you are gonna wanna change the values that you're counting evidence in Arena still to 0.645. And that,
Oh, wait, yeah. So do we get out the discussion too? Or do we-
for probably
Is that
one,
downside?
your probability of hits should be 0.6. Or count the number of successes at least that you has should be
So
like
it's
5 or 80 out of 100. Because that's the same thing that we're doing in back in chapter 1. you want to test whether
Yeah, like, yeah, it was
pi
like
is
you
equal
were
to
like
6.
rejected based
That
on
is
the
our
table,
point.
and now this is giving us
And
more.
then we use the value from the data as our count.
It's actually easier.
Count simulation that makes it extreme.
So. I don't know why we complicated that. Like, I don't know why we.
Because it's saying
so
if other points are from six, it has to be
smaller, so like a better p value, so it
Yes,
gives
that's
increase the qualifier.
And we switch that to 12.
So we-
Right.
So what's the p value?
It's point
Okay.
three slash.
That's very close.
So that means that next one. Okay, but it's still
Thank you.
positive point one five.
So
I'm
no,
just, I'm sorry.
So yes.
So what's your value?
This one down by 3.
Yeah.
So
So
point,
now it's. So for which one?
It's.
So if the p-value is larger than alpha,
Then
not
it's
the value.
then it's plausible.
Yes.
Yeah.
because if it's smaller, then you don't get the
Hey, he's here.
Oh my god, sounds like Jerry.
extra cardio.
I went back to my car didn't have one. And I go to the gas station and buy some. This faster just driving here. No, well, I don't know. I don't want to do the same mistake twice. I have an extra. Oh. 6.
Oh, okay, so the only thing that changes like.
That's how.
Okay, so this is so yes, this is so no, it's just
Yeah.
also one of the possibles.
If you value is greater, the more possible is less.
Oh, that's a good question. Yeah, so, what is? Okay, so these are all.
Or not this.
That's gonna be.
I literally done all I know.
1 week.
Same.
5.
Same, I want to see the first and second. No, first and third grades, I don't know all
I forgot all of it. Like, I knew it at the time, and I forgot all. Wait, I'm gonna see that.
The p-values are gonna.
Please tell me.
Oh, there's no level like
Oh.
Because
There's no-
6.5 has the highest.
So there's nothing to learn.
Oh, no,
For week
there's-
1, for week 6.
On either side, it's sort of.
So some.
Research
Get
labs.
a-
No, this.
Yeah, not necessarily. Don't look at me, like, I'm not-
There's nothing at all, but there is.
Okay, so I'm just not to look at the last stuff.
Yeah, there's no level.
Like, oh,
I was looking at the five equals
5 equals. And I only know one of them.
Okay, so.
I know one of them really is decent. And the rest.
Okay, so is it, what's, so is this like a point one? 0.54?
So we're still rejecting everything, we're just.
Alright.
Now we. No, we still need separate.
Isn't it, yeah, I was like, always
Yeah, 'cause
that's smaller. Now we want.
Yeah, if it's bigger than the.
Guys, erase all of them?
Oh, yeah, you can erase all.
You get all the values will change, but not all the details. But it's, we're still.
Okay, I'm gonna say it so you guys are gonna copy.
Yeah, it's really
So
sad.
you're putting 0.5 on it. It's
It's so hard. Or for each-
So that you just, you can never, you just.
Yeah, value?
And then if
Oh.
if it's
Yeah, we have that.
less than.
Yeah.
0.05?
So it's.
And it's less than possible.
Point zero zero.
Less than.
If it's less.
Okay, so this is.
P value is
Point
less
zero
than
five.
this, and then you have
And then if you get farther away from that, there gets.
0.10.
Stronger evidence, that's where it's not able to. Yep.
What was this?
0.6 or
0.1.
0.9 or 0.58. And at some point, like, cross the
Point
threshold,
two.
and then we start saying, no, we're not going to.
So we're
Point three.
rejecting that.
Okay, so this one is no, we just, this one.
The last one is.
Only the last one. The other one.
So you hold down that fast. I didn't get a single one.
Yeah.
So it's like 0.
Yeah, that makes it out.
There's no.
We're rejecting.
The last one because it's over. No, we should do this one.
No, this is not over 7.
No, 7,
right?
no, but we're using some new level.
But I don't think that matters. Yeah. No, does it? I think we started that because it's just a p value. It's a p value. This is what you want.
Okay, so anything that's.
Seeing the p value is less than or greater than?
So it's and equal to 0.05.
I don't know what I'm saying.
So it's less than or equal to?
So everything after 0.05 is
To be honest, I can never remember what you do when you know it's exactly equals to 5. So, I think I probably am not going to ask you about that in the exam.
I'm gonna say 0.5 or like.
R/P.
Let me look that up.
So, okay, so this is, so they're good at this.
Oh,
these are all p values. Yeah.
Strong greater than.
So we're totally, you don't care about numbers.
So R.
Values.
That makes sense. Okay, so
For example, the p value is less than or equal to.
beautiful.
I'm just gonna go ahead and guess that one is plus.
Yeah, no.
Because
Like,
plus,
so that's a 95 one.
plus,
Because
plus.
of-
Dang it.
Oh, okay. 1.15.
I'm gonna do a prediction. I get this right. So there's 4 here, 3, 3. Do that.
0.085.
Rejecting that.
That's right.
0.035.
No, I missed one.
Yeah, so now we're
0.014.
0.014.
Are we supposed to? Oh, like, or just as a. 0.005.
Yeah. we do.
0.050.
2 zeros and.
Alright, so. I'm not reading that whole thing.
Wow.
I think they're just saying like hypothetically, if this word.
I think I agree. So this word would be.
Yeah.
Just guessing the plural.
You're far enough away.
That's
No, only the last,
that's thing like-
so the first. Well,
Yeah, drop the fire down.
Well, she explains to you how it's like there's this plausibleness and then there would be so like right like this.
0.57,
Like 0.56 through 0.7 is like right here, right? So anything here and here. Yeah, and 0.50 lies beyond this. Yeah. I don't know how to work. No, it doesn't. She just said it doesn't. There would be.
Oh, no, that's how I was thinking.
just a
This one?
Oh.
It doesn't, because on the bottom we said.
Oh,
So, no. Yeah, so I was like, one part of your question.
0.5 is
Yeah, that was an
We're saying, yeah.
I'm confused. Yeah. I
That's
thought I knew. And it's not in here.
It is enough evidence to reject it.
Okay. So is there not? You said it's not.
No,
You
just
just
said
wrote the question.
Okay, I thought you were saying the answer.
No.
No, that, my brain wants to say. So based on the life outside of 95%. I think it's based on the consciousness. Oh. So wouldn't it be yes, because it's not. So isn't it possible that the alternative is true? Because 95% of the information is 25 or 5.
This would.
Am I confusing myself or is that?
You're on the right track.
Okay, so like,
It's, it'd be yes.
Because we're just looking at. Yeah,
Because.
yes, there is enough evidence.
Yes, there's enough.
There's enough.
This is 0.50 the final table.
I mean, it's not, yeah, I think you're right. So it's possible that alternative is within.
Oh, I get
The
it.
alternative is sort of always plausible. What we've got here is that.
But we rejected the law.
Not
This way.
There we go.
We'll say that. You bet we can.
Like your reject would make up 95%, the plausibility would make up 95%.
So that would be valid.
We
Will,
get
the confidence.
Is-
because 0.5 is
The null.
this is gonna be like.
And all that is subtracted from that.
Then you're,
Okay, so.
95% counts.
So it's all outside. Then it's.
Yeah, so,
But isn't this just a different way of?
that's, we just gotta write that, there's a 16, because 0.5 outside.
Yeah.
You know, the key values are smaller than alpha.
Okay, that makes everything for now.
Rejected.
0.01, did anything get that low? I think only like B is greater, that's greater. than
So it lies outside.
0.75, 0.76.
Yeah. Smaller.
So,
Well, that would be the.
and then I think we have to start adding other ones on the wall.
Like it makes
Yeah,
sense.
use a
to
little.
them.
Can you, okay, so we're saying.
Percentage more fun, sorry.
Start with the key values.
Yeah.
And additional,
So we need to go lower, we need to test lower.
we need to test lower until we get on the other side of the table.
But so the highest part of this is 0.75.
You have to be like.
How does
So now these cross.
this one?
But you need to test
The
lower.
link to the.
Because now we're talking.
It's not the same.
Oh, we're lower. So that's
Okay.
possible.
So now you can test like 0.53, 0.03.
Yeah.
Yes. Because.
That one is greater than just the.
These are the only two that are.
Wait, yeah.
Remember,
These are rejected, these ones are
We
rejected.
reject all the values less. So this is
But
less
this
than
is,
0.01, so
These
we
reject.
have to really go down.
So this is.
So that's. Oh, we need to put
Yeah.
key values
less
less.
than
We need to find.
0.01. We reject.
Okay, so these are, those ones would be possible.
These are, yeah.
These are
So-
possible.
Yeah.
Okay.
So these are still rejected.
Okay.
So say like opposite.
Do 0.53.
Everything above one.
Oh, I mean,
Yeah.
that, so it's 0.52. So it's.
Everything's greater.
These are the.
I mean, just do this. one.
Those are the ones that are rejected.
Yeah.
So which one are?
But it's 0.52 is.
Oh,
Okay, so 0.52.
Okay.
We're just writing on this one.
Yeah, so it's 0.52.
Alright, I'll write
So
down.
the normal.
Oh, is it only two?
Because 0.53 is exactly 101.
Okay.
She said it does not true.
And then 0.5.
So basically, we extended the.
This way.
Oh, okay.
Yeah.
Okay. Step 9.
Hey, what were the values?
0.01.
So should we do 9 first?
Alright.
0.07.
You meant to say
What?
7. Because 9 is a common goal, means 0.1.
Oh, so.
Yeah. What are we doing? Wait, where's the step 9?
And then stuff 7.
Oh,
99.
Oh, so the confidence interval is just what we said.
yes. Oh,
The 99 one excludes the 0.1.
Yeah, so that's what I just did.
so
I'm
it's
gonna write
step
the-
1 is like.
I'll try to do which is
5.
so 5.
So it would be smaller. It'd be narrower.
There, yeah, so it includes this.
You have to step back. Oh yeah, how do you?
I feel like that's worse.
So narrower because. Oh, no. So that's, so narrow because it includes this value.
That's what I do.
What, you got an 8 or 9?
Oh,
Okay, that makes sense. I got sworn I was a lighter.
sorry. Okay, no, number 8 is the same sequence.
Oh, yeah, this one's really narrow.
Okay, this is actually good.
I thought you guys
No, I
were
think- You're like, wait a minute.
good, we don't find out. That means just use 0.1, actually.
I think so. Which I mean, you can read down values for it.
I mean, you will watch. So right now.
Cool. Good job, guys.
Yeah.
It's intimidating at the beginning, just do all this stuff.
Okay.
There's a lot of things. So,
Yeah, they've done.
I want to. And I.
I studied. So the band.
I haven't even watched Lent.
Oh,
yeah.
Yeah, I haven't watched it.
You guys look.
Oh, you already did this.
No, I just have to get-
Did you touch it?
Yeah, I did.
Thank you. So what did you get?
You guys do it yet? Oh. Did you? You didn't have it?
Yeah.
Wow. That's just.
It was like 4. And you did that.
Yeah, it's like 4 like 3 houses. Like even for those, I just don't think it's without having waiting. I'll take one. So I just put that. I don't know wrong with it. I just switched it to get worse. So now you switched it about less. Like,
You guys did it? Yeah.
even if you couldn't. It's like she's like listening to her audio, she's talking the whole time.
Yeah, I did it with the group chat.
Did you guys get 100 out or?
Yeah.
I still don't even know.
Well, I did mine first and then mine comes out. Oh, no.
Oh, I don't.
I think I'm just like 1.2. Yeah, so now that you guys.
Yeah.
Okay, so what it is?
That means I did one person.
I just could go down now.
I don't know why I'm so true. But.
Worse on those.
So how do you like?
The lab, like.
I did worse on lunch.
So you can read it from that table in the same way that you read it in Excel. So what did you do with this table once you had it?
So a lot of us on Monday.
You looked
I
at
did that. I did
the
that.
values where.
I put my side and put my-
I didn't think about that.
Okay, so 90%, that's 0.1, right? Correct, so it'd be like.
This is.
And after that,
Yeah.
it's on to the next one.
I think it's just.
That's cool. That's what I just like, sit back and relax.
It's like, oh, sorry, don't. You're like, where's your computer? It's
There's a lot of
like, next, that's next week. God dang it.
Tomorrow. Yeah, and I took the notes for tomorrow, I was like, wow.
I didn't even know that.
What's consensus?
So then, so now.
I'm gonna like.
Okay.
Okay, I was thinking about you got some water on this.
But there's a lot of this.
No, it's just one minus. Okay.
I got one more. That's a good one. Yeah, I did too, so.
Same I'm taking it right now, I'm sorry.
I can try it. I really lost my test. So I can take it again.
I didn't even, they had a thing where you can like allow to get crystal 100 level, so it's like for sure. It gets better. I saw it online. The way she teaches it, it's so. I mean, sociology was definitely easy. It's just doing the like why.
All right, so let's talk about this. Let's do table 3. Can you tell us what p-value you got when you were testing whether pi was different from 0.6? Say again? 0.3080. All right. So at a significance level of alpha equals 0.05, is 0.6 a plausible value for pi? Let's do thumbs up for yes, thumbs down for no. Yeah, because our p-value is larger than the significance level. Does that prove that pi equals 0.6? No, why not? Nettie? Yeah, you can't prove the null hypothesis. It might be that there are other plausible values, and we just didn't have a large enough sample size to tell that pi was not equal to 0.6. So there are other plausible values. Maybe the truth is that pi equals 0.61. And we just didn't have a big enough sample size to tell that pi was not equal to 0.6. All right. So then you filled in this table. Can someone explain the process for making this table? What were you doing with the applet?
We were entering in the hypothesized value of pi instead of the number of probability successes.
Mhm.
And then kept everything else the same. Or not. I don't know.
Yeah, so you're putting in the hypothesized value of pi in for the probability of success or probability of heads to generate your null distribution. And then keeping the value from the data the same at 80 out of 124. So based on that, you got different two-sided p-values for each of these values. And many of you noticed that's been sort of a trend where this is the value of pi, this is the p-value. The p-values go up and then they go down. So that's in general true for when you're computing p-values. There's going to be some peak when you're testing the null hypothesis that pi is equal to p hat, the value from the data. So when pi equals 80 divided by 124, which group 5 we found was about 0.645. If we test that value, that's going to give us the largest p-value. And on either side of that, as you get farther away from that value of pi, the p-value is going to decrease until at some point you cross over a threshold where the p-values go below 0.05. And then everything inside of that interval, those values of pi are the confidence interval. Those are the values that we consider plausible values for pi. So table 4, what did you find for your 95% confidence interval for pi? 0.56 to 0.722. Cool. So tables 3 and 5, probably your confidence intervals might have been slightly different on the ends, but not a lot different. All right. So based on this, does the confidence interval include 0.5? No, 0.5 is not between 0.56 and 0.72. So if you did test whether pi was different from 0.5, would there be enough evidence to reject the null hypothesis? Let's do thumbs up for yes, we would reject the null hypothesis. Thumbs down for no, we would not reject. Thumbs up. So the answer here is no, the confidence interval does not include 0.5. So the answer here is yes. 0.5 is outside the range of values we found to be plausible. So we're going to reject the null hypothesis that pi is equal to anything that's outside of the confidence interval. All right. So then you revised your table to get down to p-values out to 0.01. So based on that, table 5, what did you find for your 99% confidence interval? 0.52 to 0.74. All right, so that is wider than 0.56 to 0.72. So our 99% confidence interval needs to be wider than the 95% confidence interval because it needs to contain more confidence. We need to be 99% confident of catching the true value of the parameter. And from the perspective of the table, we need to go out farther to get p-values that are out to 0.01 compared to how far we need to go out to get values that are equal to 0.05. So we can think about this as drawing another threshold on here at 0.01. So that interval is wider. All right. So table 3, how do you think a 90% confidence interval would compare? Sorry, say that again. It'd be less wide. It'd be narrower. Because you can draw a third threshold on here. So a 90% confidence level corresponds to a significance level of alpha equals 0.1. So where that is intersecting our range of p-values is closer in towards the center value where pi was equal to p hat. Questions about this activity? All right, we have about 5 minutes left. Let's talk a little bit about the activity from last time on using levels of significance to help us detect embezzlement. So in this problem, what was our null and alternative hypothesis? Sandra?
The null is equal to 0.301.
And what was equal to 0.301? What symbol are we using? pi, yeah, because this is a proportion. And then the alternative is that the proportion is different from 0.301. So we can use a two-sided alternative hypothesis that pi is not equal to 0.301. So then, to help us later on in this activity, let's put this into sort of words of what that means in terms of Nelson and his checks. If pi is equal to 0.301, that means that the data match what we expect under Benford's law if the checks are just for random amounts. So the null hypothesis is suggesting that Nelson is innocent. The alternative hypothesis says that the data don't match Benford's law. And that would suggest that Nelson is making up numbers to put on these checks, that the numbers on the checks contain a human bias. So that would suggest that he's guilty. So then when we come down to question 3, the Blackstone principle is that it's better to let 10 guilty people free than to convict one innocent person and make them suffer in jail. So if there's reasonable doubt about whether the person has committed a crime, then we're not supposed to convict that person. So based on that, which would be worse, a type 1 error or a type 2 error? So a type 1 error would be rejecting the null hypothesis and claiming the alternative hypothesis. So we'd be claiming that Nelson is guilty when the truth is that the null hypothesis is true. So a type 1 error is worse according to the Blackstone principle. So if we want to have a small chance of making a type 1 error, we want alpha to be small. So use alpha equal to 0.01. So the idea here is that there are fewer p-values that are smaller than 0.01 than there are that are smaller than 0.10. So when we use alpha equal to 0.01, we're less likely to reject the null hypothesis. And that includes being less likely to reject the null hypothesis when the null hypothesis is true. So that means we're less likely to make a type 1 error. Questions about this?
Is it still possible to make a check?
Good question. So yes, When you find your conclusion, you find that you reject the null hypothesis. So it looks like Nelson is guilty. So that means that either we made a type 1 error, oops, because we rejected the null hypothesis. So if the null hypothesis was false, if the null hypothesis was true, then rejecting it would be a type 1 error. Or we might have made no error. If the null hypothesis was false and we rejected it, then that's the correct decision. All right, thank you for your attention today. I will see you tomorrow for theory-based confidence intervals for report.
I